Okay, then, students, I hope so. The screen is visible. So today we are going to discuss about Taylor's principle. So already we had an idea of this through or when the class was in offline, we have taken the class. So can anyone of you tell me how does where do we refer the Taylor's principle? What was the base or what was the basic idea of Taylor's principle? Like in which topic we have learned about this? Can anyone of in the class tell me that from where we have learned this Taylor's principle and aspects? Vishnu AP?
Sir,
Yes. While discussing about
gauges,
which topic yes, correct, Vishnu. Thank you. Gauges, yeah. So we were
gauges.
discussing about the gauge design. At that time, we were discussing about the Taylor's principle. Yes, gauge, right? Gauge design, everything. Yes, that's the various types of gauges, everything. So okay. So now today, I'll just give a small introduction of gauge design. This is usually a copy of the mating part of the component being checked as it is far from its form and size is concerned. That's the main purpose of a gauge design. What is the main purpose of a gauge design? Mainly it is a copy of a mating part. Okay, mainly it is a copy of a mating part of the component being checked. Okay, it's mainly the copy of the mating part of the component being checked as far as its form and size is concerned. That's what we say. In the case of a gauge design, a gauge is usually a copy of the mating part. Okay, what is meant by gauge? A gauge is usually a copy of the mating part of the component being checked. A copy of the mating part of the component being checked. Okay, as far as its form and size is concerned. It quickly ensures whether the size of the compound being inspected is within the specified limits or not, and hence suitable for assembly. The gauges should be simple in design to enable faster but accurate measurements. This is what happens with respect to the gauge design. So now today we are going to discuss about the Taylor's principle. Today we are going to the Taylor's principle. Then with respect to the go and no go principle and the no and go gauges and the important point of gauge design. That's what. Not till VRMs you already told. So what is this like in the case of Taylor's principle? What happens? Okay, so Taylor's principle is like it is developed by relating to gauging of the component. It is mainly related to the gauging of the components. Can any one of you tell me the who has developed the gauge, who has developed the Taylor's principle? Can you name the person? I have told the class. Could you just name the person? Sriraj, could you just name the person?
William Taylor.
Yes, Sriraj. Thank you. Yeah, it was William Taylor. So what happens is William. Oh, it's already there over here. Okay. William Taylor. So what happened? Taylor's principle is William Taylor. We developed a concept relating to the gauging of the components. That is, check the specific dimensions and geometric features of a component. So what he has said here, what happens is a concept relating to the gauging of components is mainly employed. Okay, to check whether the dimensions and geometric features of a component are as per the required dimension or as per the standards. That's what, to check the specific dimensions and geometric features of a component. Then concept is it's known as Taylor principle. It is used in the design of limit gauges. It is mainly used in the design of limit gauges. Okay, it is mainly used in the design of limit gauges. That's what happens. It's mainly used in the design of limit gauges. Then Taylor's principle states that the go gauge should check all the dimensions. Okay, the Taylor's principle states that mainly the Taylor's principle states that the go gauge should check all the dimensions, roundness, size, location, etc. Okay, this is what happens with respect to Taylor's principle. So Taylor's principle mainly states that the go gauge should check all the dimensions. Okay, the go gauge should check all the dimensions, that is regarding the roundness, the size, the location, etc. of the workpiece at a time for the maximum metal condition. And no-go gauge should check only one dimension of the workpiece at a time for the minimum metal condition. That's what happens with respect to Taylor's principle. So what happens is here a concept relating to the gauging of compounds is occurring where we have been checking the specific dimensions and geometrical features. Okay, it is mainly to limit gauges. Then what happens is William Taylor developed that to check the specific dimensions and geometry are common. His concept is known as Tailless Principle, used to design limit gauges. Then Taylor's principle mainly states that the go gauge should check all the dimensions, that is roundness, size, location, etc. of the workpiece at a time for the maximum metal condition. Okay, for the maximum metal condition, and the no go gauge should check only one dimension of the workpiece at a time for the minimum metal condition. That's what happens. Then what happens over here is, okay, in case of what happens over here is, you can say the go limit and no go limit also. In the same aspect, we can say go limit and no go limit. The go limit is what means it refers that limit of the two limits of size. It mainly refers that, okay, it mainly refers that the limit of, okay, it mainly refers that the limits of two limits of size. Okay, go limit means it mainly refers to the limit of two limits of size which corresponds to the maximum material condition. It mainly corresponds to the maximum material condition. That is the presence of the greatest amount of material permitted at a prescribed surface. That's what happens in the case of go limit. In the case of go limit, it refers to that limit of the two limits. It mainly refers to that limit of the two limits of size. Okay, it mainly refers to the that limit of two limits of size which corresponds to the maximum material condition. Okay, which corresponds to the maximum material condition, that is the presence of the greatest amount of material permitted at a prescribed surface. That's what happens. So what happens is here is the go end of the gauge must go into the feature of the component being checked. Always what happens is the go end of the gauge, okay, the go end of the gauge must go into the feature of the component. Must always or must the go end of the gauge must go into the feature of the component being checked. So the go end of the gauge must go into the feature of the component being checked. The no go and the must no go into the same feature. There should be the same feature. Then the dimensions of the go and the no go ends of gauges are determined from the limits stated on the dimensions of the component to be gauged. So in this case, what happens is the dimensions of the go and the no go ends. Okay, the dimensions of the go and the no-go ends of gauges are determined from the limits. Okay, are determined from the limits stated on the dimensions of the component to be gauged. Stated on the dimensions of the component to be gauged. The, the dimensions of the go and is equal to the minimum permissible dimension, and that of the no-go end is equal to the maximum permissible dimensions. So this is what happens in the case of go end and the no go end. But at the same times, in the respect to the go limit, what happens is it refers to that limit of the two limits. It mainly refers to that limit of the two limits of size, which corresponds to the maximum material condition, which mainly corresponds to the maximum material condition. It mainly corresponds to the maximum material condition. Okay, it mainly corresponds to the maximum material condition. That is the presence of, it's mainly the presence of the, or we can say the greatest amount of material permitted at a prescribed surface. That's what we can see in the case of go limit. And in the case of no go limit, what happens is it refers to the limit of the two limits of size which corresponds to, in the case of go limit it was maximum material condition, here it will be minimum material condition. Okay, here it will be minimum material condition. In the case of go limit it was maximum material condition, but in the case of no go limit it is minimum material condition, that is the presence of at least amount of material permitted at a prescribed surface. That's what that is, the presence of at least amount of material permitted at a prescribed surface. Permitted at a prescribed surface. Then Taylor's principle states that, okay, Taylor's what happens? Taylor's principle states that the go gauge should check all the dimensions. Okay, Taylor's principle states that go gauge should check all the dimensions, roundness, size, location, etc. Okay, so what happens to Taylor's principle? Taylor's principle states that the go gauge should check all the dimensions, that is the roundness, the size, the location of the workpiece at a time. So what happens over here is the go end. Okay, the go end of the gauge must go into the feature of the component being checked, and the no go and must go into the same feature. But the dimensions, mainly the dimensions, what happens? The dimensions of the go and the no go ends of gauges are always determined from the limits. It's always from the limits stated on the dimension of the component to be gauged, stated on the dimensions of the component to be gauged. Then the dimensions of the go end is equal to the minimum permissible dimension. Okay, so the dimensions of the go end is equal to the minimum permissible dimension. Okay, the dimensions of the go end is equal to the minimum permissible dimensions, and that of the no go end, and that of the no go end. So what happens over here is the dimensions, mainly the dimensions of the go end, mainly the dimensions of the go end is equal to the minimum permissible dimension. It's always equal to the minimum permissible dimensions, and that of the no go, and that of the no go, and is equal to the maximum permissible dimensions. That's what happens. Then in this case what happens is the maximum, okay, the maximum metal condition results at the upper limit of a shaft. The maximum result condition results at the upper limit of the shaft. Okay, the maximum condition limits at the upper limit of the shaft. Okay, the maximum condition the upper limit of the shaft, and at the lower limit of the hole, and it's always at the lower limit of the hole. That's what happens in this. Then the minimum metal condition results at the lower limit of a shaft and the upper limit of the hole. That's a vice versa differences that's happening with the go and no go principle. Okay, that's happening with the no and no go principle. So see, this is the no go gauge, it's a ring gauge, bush gauge. I hope so you remember the various types of gauges which we have studied. Okay, the various types of gauges. Could anyone of you tell me what are the various types of gauges which we have learned in the class? Any one of you? Or I should ask someone. Sarun, could you tell me the various types of gauges? Mainly, Sarun Raji?
Yes, sir.
Could you just tell me the various types of gauges?
Screw gauge,
Ah, okay.
പിന്നെ ring type gauge,
Ring type gauge. Okay.
പിന്നെ plain type gauge,
Plain. Okay. Plain gauges. Okay.
പിന്നെ caliper gauge,
Caliper gauge.
കഴിഞ്ഞില്ലേ?
Okay, so mainly we will be discussing about plug gauges and snap gauges, everything, feeler gauges. There are so many gauges, right? We have, you can check the notebook. At least you might written the top name itself. Okay, so what happens is in the case of go and no go principle, the various limit gauges are available. Okay, the various limit gauges are available where the maximum metal condition results at the upper limit of a shaft. The maximum metal condition results at the upper, okay, mainly results at the upper limit of the shaft and at the lower limit of a hole, and the minimum metal condition results at the lower limit of a shaft and at the upper limit of a hole. That's what happens. Then what happens is the go and no go gates. See, this is a figure, the go and no go gates. So this is the go and no go limits of plug gauge. See, where we have shown the tolerance zone and everything. So what happens over here is in the case of important points of gauge design, before, okay, before discussing that, what happens now? The various types of gauges, like in the case of snap gauges, the go gap gauge corresponding to maximum limit of the shot. So according to the requirement, so before knowing that, we have to know a basic idea of what are the important points while designing a gauge. Okay, while designing a gauge, what are the important points which we have to consider while designing a gauge? So what happens? The form of go gauges. Okay, Mainly what happens, the form of go gauges should be a replica of the form of the mating parts, of the opposed mating parts. That's what happens. So in the case of in the case of go gauge design, the form of go gauges, okay, the form of go gauges should be a replica of the form, okay, it should be a replica of the form of the opposed mating parts. It should be a replica of the form of the opposed mating parts. Then the second one is the go gauges. So what happens? The go gauges. The go gauges enable several related dimensions. Okay, in this case, the go gauges enable several related dimensions to be checked simultaneously and hence are termed complex gauges. So in the case of gauge design, the form of go gauges, okay, mainly the form of go gauges should be a replica of the form. The form of go gauges should be a replica of the form of the opposed mating parts of the opposed mating parts. Then, go gauges enable several related dimensions to be checked simultaneously. Okay, go gauges enable several related dimensions to be checked simultaneously, and hence are termed complex gauges. And hence are termed complex gauges. Then, during inspection, okay, mainly what happens during inspection, go gauges must always be put into the conditions of maximum impassibility. Okay, so that's what happens in the important points of gauge design. Okay, what happens in the important points of gauge design is the form of go gauges. Okay, the form of go gauges should be the replica of the form of the opposed mating parts. That's what happens. The form of go gauges should be the replica of the form of the opposed mating parts. Then, go gauges enable several related dimensions to be checked simultaneously. Okay, go gauges enable several related dimensions to be checked simultaneously and hence are termed as complex gauges. So hence it is termed as complex gauges. Then the node go gauges, okay, the node go gauges are checks a single element of a feature at a time, while the no go gauges must always be put into condition where maximum passability during the inspection is occurring. Okay, at the time of inspection, you have maximum passability. That's what happens. Then what happens? With what so when we are doing all this with a gate design, what should be the material, what all factors should the material should have, it should automatically what all factors of the material should we have, we should always have very hard and wear resistant capability of the material. We should always look on or attain the hard and wear resistance, okay, the hard and wear resistance capability of the material. Then it is also corrosion resistant, to a factor that it is also corrosion resistant. And the third one is it is capable of maintaining dimensions, that is stability and form. Okay, it is capable of maintaining dimensions, that is stability and form. That's what happens. It's capable of maintaining dimensions, that is stability and form. Then one case what we can say, it is always easily machinable. It's always easily machinable. Then having uh, having low, okay, having easily machinable, having low coefficient of expansion to avoid temperature effects. Okay, having low coefficient of expansion to avoid temperature effects. That's what, to avoid temperature aspects. These are the major gauge tolerance, gauge making tolerance aspects. Where what happens, the hard and wear resistance, corrosion resistance will be there. Then also capable of maintaining dimensions, that is stability and form. Then easily machinable. Then having low coefficient of expansion to avoid temperature effects. Having low coefficient of expansion to avoid temperature effects. These are the main traits of the gauge tolerance. That is the gauge makers, the material for gauges. Now we comes with the gauge tolerance. That is the gauge makers tolerance, and we were discussing about the wear tolerance. Okay, so this all we have discussed before in the class, but we'll have a thorough revision. Okay, since you have the third and the fourth module for your coming series too. Okay, so gauge tolerance, gauge makers tolerance, where what happens, it is economically impractical, it is economically impractical to manufacture gauges. It is always economically impractical to manufacture gauges to their exact size or dimensions. Okay, so what happens to their exact size or dimensions? So what happens, dimensional variations arise due to the limitations of the manufacturing process, the skill of operator, or some permissible deviation in accuracy must be assigned for the gauge manufacturer. But this tolerance is always allowed in the manufacture of gauges is termed as gauge maker's tolerance or manufacturing tolerance or gauge tolerance. Then limit gauges are usually made 10 times more accurate than the tolerance they are to control. So that's what happens with respect to the gauge maker's tolerance. That what happens because it is economically impractical. It is always economically impractical to manufacture. Okay, it is always economically impractical to manufacture. It is always economically impractical to manufacture gauges to their exact size or dimensions. Okay, gauges to their exact size or dimensions. Okay, the dimensional variations arise due to limitations of the manufacturing process. Mainly, the dimensional variation arise due to the limitation of the manufacturing process, then skill of operator, etc. Are so some permissible deviation accuracy must be assigned for the gauge manufacturers. Okay, must be assigned for the gauge manufacturers. That's what they are saying. Okay, so in the case of gauge makers tolerances, this is the what the major factors are happening. So during inspection, what happens? During inspection, okay, what happens in the case of when with respect to gauge makers and wear allowance, what happens during inspection? Like at the time of inspection, mainly at the time of inspection, what happens? The measuring phases of the go gauges constantly rub. The measuring phases of the go gauges constantly rub against the surfaces of the workpiece, against the surfaces of the workpiece in inspection, thereby suffer wear and lose their initial dimensions. This is what happens in the case of wear elements. In the case of wear elements during inspection, in the case of wear elements during inspection, the measuring phases of the go gauges. Okay, during the in the case of wear elements, the wear elements during inspection, the measuring phases of the go gauges constantly rub against the surface of the workpiece in inspection. During inspection, the measuring phases of the go gauges constantly rub against the surface of the workpiece in inspection, thereby suffer wear and lose their initial dimensions. Due to this wear, the size of the go plug gauges decreases. Okay. Mainly due to this wear, the size of the go plug gauge decreases, but that of the snap gauge or ring gauge increases. And some wear elements is added in a direction opposite to the wear to increase the service life of the gauges, mainly to increase the service life of the gauges. Then, a wear elements of 10% of gauge tolerance is widely accepted in industries. A wear elements of 10% of gauge tolerance is widely accepted in industries. Then, the no-go gauge. Okay, the no-go gauge does not undergo any wear during inspection. The not-go side should enter or pass, as it seldom engages the workpiece. Hence, there is no need to provide wear allowances in the case of no-go gauges. So, the no-go gauges always not go any and what engages workpiece. Hence, there is no need to provide the wear allowances. Meaning, it is no need to provide the wear allowances in the case of the no-go gauges. That's what happens in the case of no-go gauge. So these are the cases of the wear allowance. Okay, these are the cases of the wear allowance, and these are the materials for the gauges. That's what happens. So here what happens is like in the case of wear elements, these are the main aspects where we have the various types of gauges. So in this case what happens, in this case what happens is it is economically impractical. Okay, in this case mainly it is economically impractical to manufacture gauges to their exact size or dimension. It's mainly impractical to manufacture the gauges to the exact size and dimension. So what happens over here is the gauges. What's the main purpose of the gauges? The gauges are mainly used. Okay, the gauges are mainly used as per the requirement. Okay, as per the requirement. So it's a process where it helps in easy factors of the hence. Then what happens? Now we can say in the case of okay, in the case of what? In the case of The feature of size. It mainly refers to any surface or set of parallel surface associated with size dimension. Then least material condition. It mainly refers to the size of the condition where at least the amount of material yet remain with the tolerance zone. The large hole, small hole, all this. So all these gauges also comes in the consideration of the mainly with the shaft and holes also. Okay, mainly with the shaft and holes. That's what happens over here. Then in the case of this go and no go limit gauges, okay, mainly what we have the tolerance zone. Okay, what we can say, we have the tolerance zone. So can anyone of you tell me what you mean by tolerance zone? We have already discussed. Can anyone of you tell me what you mean by tolerance zone? Nived Kumar, could you just tell me what you mean by tolerance zone? Nived Kumar? Okay, he has left the meeting. So then we can ask Muhammad Fardeen, could you just tell me what you mean by tolerance zone? Muhammad Fardeen, could you hear me?
Yes, sir.
No. Could you just tell me what you mean by tolerance zone? We have already wrote in the notebook before with respect to the gauges. Gauges. You don't remember?
Sir, അറിയില്ല.
predicted,
Okay. What about Nived Kumar? They joined back. Okay, then I should. Asaf, can you tell me what you mean by tolerance zone?
Sir, zone between maximum and minimum limited size.
Repeat.
It's a zone between maximum and minimum limit size.
That's what. That's what. Correct. Exactly. That's what. The tolerance that is bound by the two limits of the size of the part is called tolerance. That's the maximum and minimum. It always refers to the relationship of the tolerance of the basic size. That's what happens. Okay. That's what we can say the tolerance zone. Okay. So it is mainly the bound by the two limits of the size. Okay. It is mainly bound by the two limits of the size. That's parallel or least. That's what we say. Two limits of the size. That's parallel or least. That's what happens in this case. So see, in the case of we can, as I have told, manufacturing cost and work tolerance. So this is the basic relationship between work tolerance and manufacturing cost. So tolerance is always the trade-off between the economical production and accuracy required for proper functioning of the material, which will be always resulting in the manufacturing cost as well as the production cost. Okay, that is the, you see the graph, which shows the relationship between the work tolerance and the manufacturing cost. That's what we are saying. So as you are told, what happens is it is always regarding the tolerance. So which is whatever tolerance, it is the bound, that tolerance is bounded by the two limits of the size of the part. It is mainly bounded by the two limits of the size of the part, which is called tolerance zone. Two limits of the size of the part, which is called tolerance zone. That's what happens. In the case of tolerance zone, what happens is, okay, the tolerance that is bound by the two limits of the size, the tolerance that is bound by the two limits of the size of the part. That's what I say. It is called the tolerance zone. It refers to the relationship of tolerance to the basic size. It mainly refers to the relationship of the tolerance to the basic size. That's what happens. Then what we are saying, the tolerance is always between the trade-off between the economical production, means on the economical. So always the production cost may vary and always the production. So there will be many aspects, there will be various or many aspects mainly regarding with the tolerance feature. Like what? Like you can say that it will be mainly the economical production, the accuracy, the precision, the trade-off feature, and all other features will be always added regarding the manufacturing cost and work tolerance, which is always the tolerance, which is the trade-off. Tolerance is the trade-off between the economical production and the accuracy required for proper functioning of the product. All these factors, okay, all these factors are to be considered or are under consideration regarding the manufacturing cost and work tolerance where it has to be done. So it is always related. It's always related with the material which has been produced. So what happens is that it should be an economical production and the accuracy should not be in compromise. At the same time, it should not increase the production cost. Only then it becomes a very successful product. That's what happens. Only then, only it becomes a very successful product. Okay, that's what happens over here. Then in this case, what happens? The no-go gauge or plug gauge, all these factors, all this plays a very important role. Okay, it all what happens? These gauges not only controls the diameter in any given section, but ensures also the case of shaft and bore, shaft alignment or bore's alignment. Okay, so however, the degree of ovality cannot be checked using the gauges, but what happens? It can be made from a pin by replacing a pin of different gauges. It can be checked. So that's what happens over here in the case of gauges with the help of the basic Taylor's principle. So always in the case of gauge maker, but we will be having a gauge maker's tolerance with respect to the wear allowances of the various factors. Okay, so then we will be reading with the different types of gauges. I hope so you remember the different types of gauges employed. Okay, so it was the limit gauges, plug gauges. Okay, we have already learned that all plug gauges, ring gauges, snap gauges, single bed gauges, plate snap gauges. Then it comes to the miscellaneous gauges. So when we say to the miscellaneous gauge, what it is a gauge which is required for the complex structure, that is a company will be manufacturing a specific component. Okay, it may be some lakhs or thousands for various products. And what happens? We will be making a gauge design in order to evaluate the dimensions and to check whether the product is under the feasible study. That's under the tolerance, wear elements, all that factors are considered, and we are making a gauge design in order for checking the fact. And why do we make such a gauge design for checking the product? What are the advantages, or why do we do that? Can anyone of you say? I'll ask to Karthik. Karthik, could you just tell me what are the factors, or why do we do like that? Why do we make a gauge design in the case of production? Karthik. Karthik Koteri, are you available over there? Andrew Suresh. Andrew Suresh,
Yes, sir.
could you just tell me why do we make these gauges for this purpose? Why do we use the gauges for this purpose?
Internal dimension, external dimension.
Okay, that's right. It is also for measuring the dimensions, inspection, everything. So why do we use these gauges? For that, we have various types of advanced normal measuring devices which we have already studied in this module. So what's the purpose of these gauges for this one?
That's sir.
Anyone of you? Rahul, Rajiv? What is the purpose of the gauges?
So for correct dimension accuracy.
For correct
കറക്റ്റ്
dimension.
ഡയമെൻഷൻ കിട്ടാൻ വേണ്ടിയിട്ട്
Yes, I agree. For correct dimension accuracy to attain. So, what is makes this gauges to make a manufacturing company? We will be having vernier caliper, various types of measuring instruments. You remember? I hope so. So, why do we use these gauges? Okay, you are telling accuracy, precision, everything. Other than that, what is the basic? What is the factor which makes this companies to adopt these gauges?
To ensure the required degree of interchangeability.
Other than that, it ensures and it saves the time, since why it is almost, I told right, it is almost what starting itself I have told it is always normal the replica of the component So the dimensions measuring will be simple. That is what means a gauge is usually a copy of the mating part of the component being checked. That's what. That's what I said at the top, starting of the class itself. That's what we gauge. It's usually a copy of the mating part of the component being checked as far as from the form and size is concerned. In order to check the form and size to the required extent. For that purpose only, we are always using the gauge design or gauge. Okay. As you told, it is also an inspection tool, or it is used for measuring internal and external threads. Everything is fine, but we can measure it at a faster rate. Okay, so always what happens, we can always be measuring it at a normal, not a normal, at a faster rate. That's what happened with respect to the gauge design. Okay, it is always normal at a faster rate. So this is what happens with respect to the gauge and with respect to the no-go gauge and the go gauge. And when it comes to the limit, what happens? That's the material condition. That's the presence of greatest amount of material permitted in the prescribed surface. And in the case of no-go limit, it is the minimum material condition. It is always the minimum material condition. It is always the minimum material condition. That is the presence of the least amount of the material permitted at a prescribed surface. That's what happens over here. Okay, so today we have discussed about the Taylor's principle, go limit, no go limit, go gauges, no go gauges. Okay, no go gauges. Then also the materials which I have taken, then gauge maker's tolerance and wear allowances regarding this. So gauge maker's tolerance and also the Taylor's principle also by William Taylor. Okay, so we'll stop for today. Okay.